Welcome to Agricomp biogas plants. Our anaerobic digestion systems are designed for agricultural operation and use for slurry, manure and crops to generate renewable electricity and heat. Agricomp can provide plants in a range of sizes to suit your needs. From 100 kilowatt to 2 megawatt, we match your manure, slurry and crop to develop a solution that's right for you. Our proven technology attracts financiers who can provide the right funding to make renewable energy your future. The biogas plant consists of three main parts: the feedstock storage and preparation area, the digester tanks and the combined heat and power housing, or CHP. The digester tanks are built of concrete with internal heating circuits from the CHP engines. They include an effective paddle stirring system, a sustainable timber roof, a flexible gas storage dome, and digestate storage that together provide a robust and economic biogas plant. Whether it's crops grown on your farm or slurry and manure from livestock, Agricomp biogas systems can accept a variety of materials: maize, grass, fodder beet, indoor and outdoor pen manures, chicken litter and slurries. Each biogas plant's input is unique. Manures vary with feeds and crops vary with geography and climate. Dry matter contents differ across the country, from East Anglia to Northern Ireland, Scotland to Cornwall. Agricomp will help you understand the best way to manage these feedstocks. Silage and manures are placed into the solids feeder from storage clamps. The Agricomp feed system is an extremely robust and energy efficient system, requiring loading just once or twice per day. The system continuously manages the materials into the digester, allowing you to get on with the day-to-day management of your farm. Hopper capacities range from 3.5 to 50 cubic meters and are designed around your feedstock materials. Capacity can be further increased with a push-off trailer, meaning more efficient use of your time. Materials fed into the hopper are pushed onto multiple augers, which mixes and breaks up the feedstock. These augers feed material onto a screw conveyor and up into the primary digester tank for the first stage of the anaerobic process. Liquids and slurries are pumped into the vessel from a separate pre-pit holding tank. In the digester tank, the chemical compounds are broken down by the naturally occurring anaerobic microbes. To optimize this process, the materials need to be thoroughly mixed and agitated. This mixing is a key component to successful biogas production, and the Agricomp patented paddle system achieves excellent mixing whilst having very low energy requirements. The four slanted paddles move in slow rotation, keeping the materials in suspension throughout the digestate mass, which prevents the buildup of surface crusts or floating or sinking layers in the tanks. Agricomp is unique in incorporating a sustainably sourced timber structure between the digestate and gas storage. This timber performs well in the anaerobic environment and provides a good surface for sulfur-loving bacteria to fix the hydrogen sulfide from the biogas and convert it into elemental sulfur, which is useful in crop development and maturation when applied to land in the digestate fertilizer. Agricomp concrete digester tanks are heated through a series of pipes that are connected to the CHP engines. Once in the vessel, the feedstock is warmed and stirred, creating optimum conditions for the anaerobic microbes to start to break down the proteins, fats, and carbohydrates to create valuable biogas. A network of pipes controls the flow of gas from the flexible biolean storage to the CHP engines. Pipes also control digestate between tanks, the heating circuits, and hydrogen sulfide removal process. Above the timber ceiling of the tank sits the gas storage area. This is a cost-effective and flexible method of gas storage and negates the need for separate buildings or vessels. The biolean membrane provides flexibility for periods of variation in gas production and engine servicing. An added advantage is that the shape of the biolean provides a very simple indication of gas storage levels for the operator just by looking at it. Biogas consists largely of methane and carbon dioxide. It also contains hydrogen sulfide and ammonia, as well as traces of other gases. The temperature in the digester is over 40 degrees, so the gas is warm and saturated with water vapor. Agricomp's laboratories help you understand the biogas potential of your materials during the design phase. And when operational, frequent analysis of the digestate helps keep the plant stable and gas yield maximized. We provide a suite of tests to understand the biology within the digesters. We work with the operators of our plants to help them understand the importance of the nutrients in their feedstock and how to maintain a good biology. Slurry and biomass are decomposed in the digester by anaerobic methane-forming bacteria. The warm, moist biogas is cooled before reaching the engine to reduce the moisture content and then compressed through an active carbon filter where H2S, not dealt with by the natural process in the digesters, is removed. From here, the flow of the clean gas is regulated and sent via a meter to a turbocharger and into the combined heat and power engine system, or CHP. The engines generate electricity which is sold to the grid and also qualifies for government incentives through the feed-in tariff, or FIT. The engines range in size from around 100 kilowatts to 340 kilowatts. The ability to provide consistent electricity generation into the grid is key to getting the best price from the utility companies, and so for larger plants, Agricomp recommend 2 or more engines. This allows routine servicing and maintenance to be carried out on one engine whilst the others remain in operation. Agricomp have chosen an incredibly efficient series of engines which are rated up to 45.5% electrical efficiency. These engines are turbocharged and also incorporate state-of-the-art Blue Rail technology. With Blue Rail, a small proportion of the biogas is ignited in a specially developed pre-chamber. This produces a jet flame that ignites the gas-air mixture in the standard combustion chamber and provides a far more efficient power generation. The biogas plant is monitored and maintained via a control board, which regulates all aspects of the plant operation and alerts the operator of any changes that need to be made. The CHP engines also generate heat, which is transferred via a heat exchanger to the water heating circuits. After the tanks are heated and enough heat remains for external heating and drying processes, which may be eligible for the renewable heat incentive. The whole process is designed for simplicity. The feedstock loading, digester management, and processes such as desulfurization have simple controls which are all easily understood. Biogas, created by materials from your farm, is an excellent fuel. It's safer than propane and can be truly renewable replacement for gas from fossil fuels. Some of the heat produced by the CHP is used in the process. The remainder can be used for drying of crops, biomass and digestate, and for pasteurization. Although the digester at normal temperatures effectively kills weed seeds, pasteurization is an added measure that increases biosecurity and protects the market for the digestate. Heat networks can be developed using hot water from the CHP and can heat glass houses, buildings or nearby communities through a network of district heating pipes. Specialist contracts can install such systems with minimum disruption by channeling with compressed air. Once in place, these systems can provide a renewable source of heat for communities surrounding the biogas plant. It's great to see these sorts of renewable energy schemes being developed and providing something back to our community. The Agricomp technology is extremely energy efficient. The mass balance shows 50 cubic meters per day of inputs, produce enough biogas to generate 0.5 megawatt of electricity. The low parasitic load of the plant means that 95% of the electricity is exported to the grid. And there is enough surplus heat produced which can be used for beneficial uses such as drying and pasteurisation. The UK farming industry is at the forefront of the change for a sustainable future. Agriculture can lead the way in meeting the government targets to provide 15% of renewable energy by 2020. Biogas development is supported by incentives such as the feed-in tariff, which is an additional payment above the sale to grid price for electricity, and by the renewable heat incentive for heat and biomethane usage. These help to ensure your anaerobic digester plant provides you with a long-term and stable source of income whilst protecting the planet. Renewable energy is a key element in protecting our environment and safeguarding it for our children's future. Burning fossil fuels emits greenhouse gas into the atmosphere, releasing them from the world's natural carbon sinks and upsetting the delicate balance of the Earth's ecosystem. Unchecked, the consequences of continuing to use non-sustainable fuels can only lead to environmental disaster. Agricomp biogas plants are part of the solution to ensure that the Earth's energy balance is maintained. Generating renewable power and applying the liquid digestate as a fertilizer to the land supports the carbon cycle and provides a rich source of nitrogen, phosphate, and potash, replacing unsustainable man-made fertilizers. With an Agricomp biogas plant, you can be part of the energy solution and join over 800 farmers who have chosen Agricomp biogas plants to help fuel the future.